All right, well, good evening, everyone, and thanks for coming to the meetup. We're going to talk about auto-scaling and load balancing on Google Compute Engine. Just by show of hands, how many people are using Compute Engine or Google Cloud Platform in one sense or the other? Okay, just a handful of people. It sounds like maybe some people not so much. Good, so this will be a good intro. Please, I think a lot of you have signed in. I'm also going to pass around this sign-in sheet. And this is just if you want to get an email from me personally. I promise I'm not necessarily over any like email lists. I'm literally just going to send a follow-up email asking if you want more info or if you want to come to the next event, things like that. So I won't sign you up for any spam. I promise that. And then all of today's content can be found at that URL. I'll also post this to the meetup group so that later on you can take a look at what we're going through. Everyone, yep, was there a question? Yeah, sure. Okay, you can go ahead and take a picture of that. So I will post that to the group as well. And as always, make this interactive. If you have any questions, don't wait to the end. Just raise your hand or ask a question. And everyone likes free stuff, so here's $500. If you go to cloud.google.com/starterpack and you use that code Seattle Meetups, you can get a $500 starter credit applied to your project. This is only for new projects where you haven't already done this. So if you've already applied a credit, you can't use another one. But if you're brand new to the cloud, go ahead, sign up, and get $500. So you do have to enter your credit card first, but you will get the credit. All right, so here's what we're going to cover tonight. We'll talk a little bit for about 5 minutes about the cloud platform itself. Then I'll dig right into it. This is going to be step-by-step in the command line. We're going to set up a Redis backend and put some network load balancing and auto-scaling on that. Then we'll go into the HTTP front-end side of things. We'll set up those front ends. We'll put in load balancing and auto-scaling. And then you guys can ask any questions. So I think this will take about half an hour to go through step-by-step. All right, so an overview real quick. It seems like some of you weren't aware of Google's cloud platform or aren't currently on it. Overview, we have a cloud platform. Many people don't even know that we have one. We have compute, storage, app services. If you need virtual machines in the cloud, if you need raw infrastructure, you can get that on Google Compute Engine. You have root access to virtual machines. You can install whatever you want in them, configure them any which way. We're going to be doing most of our demos tonight on Google Compute Engine, setting up all this auto-scaling and load balancing. There's also Google App Engine. That's our fully managed platform as a service. If you're building a web app that you need to scale from a single user to 1 million users, App Engine is perfect for that because it's a web stack that Google has built, and we manage all of it. So you never have to worry about managing data store or memcache or task user, any of that. We've already configured that. We manage it. We auto-scale it. So it's a really good platform if you're building a new application from scratch. Storage, you have cloud storage. If you need to upload petabytes and petabytes of data into the cloud, ideal place to do that is Google Cloud Storage. We have massive storage capacity, as I'm sure you can imagine. It's also great if you're building like a video sharing site or a music sharing site, or if you have static content that you want to share around the world, upload that to cloud storage, mark it as public, and then you can take advantage of the edge cache that Google has built out around the world, so you can use that edge caching and accelerate delivery to your end users. Cloud SQL, fully managed relational database in the cloud. Cloud Data Store, fully managed NoSQL-based data store in the cloud, so you can scale out to millions of transactions per second. And then you also have app services like BigQuery. If you're doing big data analytics, everything's really into big data these days. BigQuery is an analytics platform that we developed at Google to perform analytics on our own weblogs. It's based on a technology called Dremel. It enables you to write SQL queries against literally hundreds of terabytes of data, and you'll get a response typically within 5 seconds or so. It's blazing fast. It's really incredible, and it's available to the public for just pennies on the dollar. So high-level overview, that's our cloud platform. One of the key differentiators of our platform is our global OpenFlow network. Google has one of the largest networks in the world. We own all of the fiber connections between our data centers. We own transatlantic, trans-Pacific cables. And what this means is that it's a very high throughput and very low latency connections between all of our data centers. We also have many points of presence around the world, so it's going to be a very short number of hops from your end users to any one of Google's points of presence. So if you need to build a globally available application, something that's very close to your users, a very short number of hops away, there's no better place to do that than on Google's network. We're constantly improving the network. This is just some benchmarks from last year. Our baseline from just a year and a half ago, this was throughput for a single TCP stream on a, I think it was an 8-core, 16-core machine. It just topped out at over 2 gigabits per second. And just internal improvements that we're constantly doing, we've been able to increase that 5x, so you can get close to 10 gigabits throughput on a single instance. So this is just an example of the kind of improvements that we're constantly driving on the cloud platform. Cloud computing patterns that we're going to be addressing today: unpredictable bursting. If suddenly your site is on the front page of the New York Times and everyone's going to that site, you need to be able to serve requests. So to handle that kind of unpredictable bursting, you want to set up on an infrastructure that can easily handle that kind of auto-scaling, that can burst out to hundreds or thousands of cores. Again, ideal place to do that, Google Cloud Platform. And also predictable bursting if you have a banking website or something that's being heavily used Monday through Friday, 9 to 5, but not so much at nighttime, not so much in the weekends. The perfect use case, again, for cloud computing, because you're able to spin these machines up and down, and you pay only for what you use. All right. On to the meat of what we're talking tonight, though. That was kind of my cloud sales pitch. Hopefully you're sold on that. Let's talk about why load balancing on Google Cloud Platform. First, it's really simple. You just run a couple of commands that we're going to go through tonight, and suddenly you have the same load balancing infrastructure that we're using at Google to power your own website and your web service. It's scalable. You're using Google front ends in front of your own application. So you can imagine the kind of scale that Google has to handle. Millions and millions of requests, and your application is going to be just a very small fraction of that. So we're going to be able to handle spikes in requests to your app. Performant, it's very fast. Like I mentioned everything about the fact that we own all the fiber between our data centers. We have all these points of presence, and we're constantly investing in finding ways of shaving off hundreds of milliseconds of response time, because it means improvements to our business, but it can also mean benefits to your business as well. It's highly available. I'm going to show you how we can set up a cross-region global load balancing, where you have backend servers in Asia and backend servers in the US and backend servers in the EU. And you want your end users' requests to be routed to the servers that are closest to them. You can do that with Google Cloud Load Balancing. And finally, affordable. I think it's something like a ½ cent per gigabyte plus a very low hourly charge. So it's very nominal charge to get this really powerful infrastructure. Okay, so let's get started. This is what we're going to create, and we're going to create it from left to right. I'm going to start by creating a, yes, there's a question.
The load balancing, is that across your data centers or just within a data center?
It is across data centers. So you have a single global IP address, and that will automatically route requests to the backend service that's closest to the user.
If we could, let's try to repeat the questions for that.
Oh, yeah, sorry. The question was, is the load balancing global, or is it limited to one data center? And the answer was that we will route, it is a single global IP address, and we route requests to the backend service that's closest to the user. Okay, so this is what we're going to create. We're going to start by setting up our Redis-based backends. I chose Redis just because it's relatively straightforward to scale the read replicas. It's a little bit challenging to scale other database platforms. So Redis is pretty straightforward. You just have a master and you have some slaves that slave off of it. I mean, it's pretty easy to set up. I'm going to set up a master instance, 2 read replicas with auto-scaling that slave off of that master. And then we're going to have a different network of HTTP servers. These HTTP servers will auto-scale as well, and they'll make requests to the master and to the read replicas. Some prerequisites if you're going to do this afterwards. You need a Google Cloud project with Billy enabled, and again, you have that $500 credit, so that's a nice getting started guide there. Download the Google Cloud SDK. If you're running on Windows, it requires Python as well, so you'll need to download Python and install it on Windows. Another thing that you need to do is you need to install the preview components of the Google Cloud SDK. So this is the command you run to do that, gcloud components update preview. That will install the preview components. Some of the stuff that we're talking about in this talk are in preview, are in beta, so they're not baked into the final version, which is why we're going to prefix them with preview. You'll also need to enable instance groups, manage instance groups, and auto-scaling. And finally, be comfortable with the command line. Everything that I'm doing today is on the command line, but you can also do it through the web console. You can do it through REST-based APIs. So I don't want you to get the impression that you can only interact with Google Cloud on the command line. It's kind of really difficult to interact. That's not the case at all. You can point and click all of this stuff. I'm just doing it on the command line because I want to share it with you guys, and it's much easier to do that through a simple script. Okay, so the first thing that I'm going to do is I'm going to create 2 networks in my cloud project. So let me go ahead and do this. I'm going to get my phone opened up here so I have my little cheat sheet so I can read it as I type it in. 1 second here. Okay. So here's my prompt. You guys can see that. I'm going to say G Cloud Compute Networks Create. I'm going to create a network called Redis Network. I'm going to specify an IP address range for all instances attached to this network. And this is going to be in my Google Platform demo project. Okay, so that's going to run and set up that network. Oop. Networks create, of course. Here we go. And I'm also going to create a network for my HTTP servers. It might take a second here. There we go. Cloud Compute Networks Create HTTP network. Range IP address, internal IP address range for that will be 10.200.0.0. Yes, for the internal IP addresses, yeah. Okay, so we're creating 2 networks. We're going to attach our Redis instances to the Redis network, HTTP instances to the HTTP network. And now what I've done in advance is I've created this this container .yaml file. And what I'm saying here is I'm going to launch some Compute Engine instances with the Docker agent installed, and I want that Docker agent to pull data from this repository. This is just the stock Redis Docker file that's in the public repository. So I'm just going to pull that stock Redis image onto my Compute Engine image when I launch it. So go ahead and create that container master YAML file. And then what we're going to do is we're going to create an instance template from that file. So let me go ahead and create this instance template and explain what I'm doing as I type it. Okay, so I'm going to say G Cloud Compute Instance Templates. We're going to create the Redis master template. The Compute Engine server image we're going to use is an image called Container VM V2014-0929, very memorable name there. The image project is in Google Containers. And we're going to create, so what this is going to do is we're saying we want to create a cluster of machines that are this F1 micro. This is one of our shared core instances. I'm using the shared core instances because I want to show the auto scaling, and it's easier to do that in a small instance. We're going to attach it to the Redis network. And we're going to, when we launch this cluster, we're going to, oh, misspelling this. We're going to use this manifest file that we just created, this container master. So we're going to specify that this container master.yaml file is what we want to have installed on that image. Okay. So that was a lot to look at, but now the output of this command, we're going to create an instance template here. And what is an instance template? An instance template doesn't launch a cluster. It just specifies what the cluster should look like, the instance types, the operating system that you want installed, the network that you want to attach the instance to. So you can specify all of these things in a declarative format. And once you create the instance template, then you pass that to a managed instance group, which is going to launch those machines using that instance template. Let's go back here. I created the instance template. And let's go ahead and create a managed instance group. So again, the managed instance group is going to read that template and actually create the cluster. We'll say G Cloud Preview Managed Instance Groups. We're going to do this in US Central 1F. That's one of our availability zones. We're going to create the Redis master group. Base instance name is going to be Redis master. So that when we actually launch the server, it's going to be prefixed with Redis master dash some random stuff after it. Doing this in Google Platform Demo. We're going to create a cluster of size 1. It's just going to be a trivial example. We're not going to auto-scale this one or grow it. It's just going to be a single node. And the template we're using is the template we just created, that Redis master template. Okay. What managed instance groups do is they will launch a cluster of whatever size you specify. And I'm going to go to the console here. I'm going to refresh it. It will make sure that that number of instances is always running. So there we go. We've launched that instance, that Redis master. Let me zoom in here. So it's launched this instance, and if I click that and hit delete, it's going to relaunch it. So it's going to make sure that I always have the number of instances running. So you can use manage instance groups to make sure that you have a highly available application, make sure that your instances are always up. All right, so once I've created the instance template, let's take a look at our read replicas. So here's a container replica YAML file. Let me see if I can zoom in. This is a little bit small here. Okay. Well, so basically what I've done here is I've created a Redis replica that listens on port 7000, and it slaves off of an environment variable called a Redis master IP address. And I need to set the value of that environment variable to the internal IP address of the Redis master. So these read replicas are going to be listening to that master internal IP address. So I'll do that. I'll go back to my Cloud Console. I'll click on my Redis master. You can see here that there is an internal IP address for this Redis master. I'll go ahead and copy that. And I will paste it into my container replica YAML file here. I'll save that. So now when I launch that cluster of servers, they're going to be listening to that IP address, listening for any changes from that Redis master. Does that make sense? More or less? Okay. So now that I've modified that container replica YAML file, what I'll do is I will create an instance template out of it. So let's go ahead and do that. G-Cloud compute instance templates. We're going to create a Redis replica template. And the image is going to be this container VM. And the image project where that container, where that OS image lives is Google Containers. I want to emphasize that you don't need to use containers to do this. I'm only using containers because it is easiest for me to share this demo with you rather than having to share server images that are all customized. It's just much easier for me to point you to a container repository. I'm going to attach this to a Redis network. We're going to point to that container YAML file that I just created. And that file was called containerreplica.yaml. Okay. I'm creating that instance template. And I'm not going to create the cluster of read replicas yet. Was there a question?
Yeah, the question is, in your YAML file, there was an image reference. Where is that image actually located?
Oh, that's a good question. The YAML file references an image. I created it and I uploaded it to a public Docker Hub repository. It's called mgrabowski/redis-read-replica. So anybody can actually reference that public Docker repository and download it. So I uploaded it to Docker. Question?
So the containers, the backend you're using right now are containers?
The containers I'm using on the backend are Docker containers. That's correct.
So you're pulling directly from Docker containers?
That's correct. I'm using what I'm doing is I'm launching virtual machines in these clusters that are container optimized images, which means that when they start, they automatically have the Docker agents running on them. And what these container YAML files are doing, we're passing that into the Docker agent. We're saying, pull these Docker repositories, map these ports, set these environment variables. Yes, exactly. Yep. The thing that, what I'm doing here is G-Cloud Compute instance templates, create the template. See this -- image container VM v20 whatever. If you're not using containers, you would just say -- image Debian or -- image CentOS or SUSE or Red Hat, whatever. But I'm using this special thing called container. This is a special Google build of an operating system that has the Docker agent installed on it. Okay. There's another question? No? All right, so before I actually launch the cluster, what I'm going to do is I'm going to create a target pool. Let me go ahead and do this, and I'll explain what that is. I'm going to say G-Cloud Compute Target Pools. I'm going to create the Redis read target pool. Project is Google Platform Demo. And the region is US Central 1. Go ahead and create that. All right, so what is a target pool? A target pool allows you to do some pretty interesting stuff. It is the target of a forwarding rule. A forwarding rule is a single externally available IP address. So requests go to that IP address, and then they are sent to a target pool. And you can set up a situation like this, where you have a primary target pool and a backup target pool. And you can health check both of these pools. You can set thresholds so that if a certain percentage of your primary pool fails the health check, those new requests will be routed to the backup pool. And that backup pool can be in a different zone in the same region. So this is a way that you can build a high availability architecture. Yep.
Can you define that health check, or is it a predefined thing?
It is an HTTP health check. You define what URL and what port, but it is an HTTP health check. Yep.
And it just looks for any HTTP error code, or?
It looks for, I believe, error code 400 or something that's not code 200. I forget the exact response that it looks for. Between checks?
No, instead it's that's the normal way.
So like you need to like have a timeout basically. I believe you can specify that. You can specify that with the HTTP health checks. I can't remember if you can do that with.
That's an active check then. That's an active. Separate from the request flow as an active check.
Correct.
And then does it also load balance on the natural request flow? Or basically, does it mark an instance unhealthy if it's returning bad HTTP to a normal request, not a health check request?
No. So the question was, does it mark the instance unhealthy if the instance is returning bad HTTP to a regular request? It only marks the instance unhealthy if it returns an HTTP error code to the health check request. Yep.
Way to have the errors as a normal activity.
Question was if there's a way to have errors in the normal requests go back to the health check. Not that I'm aware of. Not that I'm aware of. I don't think there's a way to sort of redirect the output to the health check. Yeah. I mean, you could health check the default, like the same URL that you're having your traffic go to. So if everything's handling everything at like some URL pattern you specify, you would health check that URL. And basically, then if your users are getting errors, then you would get the same error as well. So that's one alternative. But so some other things to point out about our health checks. If a target pool is marked as unhealthy, we won't terminate connections to that pool. We'll keep them open. We'll route new connections to the backup pool, but we won't terminate connections to a pool that has been marked as unhealthy. And once health checks succeed again on the primary pool, we'll send traffic back to that primary pool. Okay. So let me go ahead and create the manage instance group now that I've created that target pool, and I'll go ahead and type that in. G-Cloud preview managed instance groups. Create this in US Central 1F. Create Redis read replica group. Base instance name. We're going to prepend Redis read replica to all of our instances that we launch. Project will be Google Platform Demo. Of course, you change this to whatever your project name is. We're going to start out with a read replica pool of size 2, using the template that we defined 2 steps ago. This replica template, and using this target pool that we just created in the last step. We're going to say attach this to a target pool, the one called Redis read target pool. Okay, so let's go ahead and run that command. And once this completes, then we can go back to the console. We'll go back to our VM instances, and we'll just make sure that those Redis, there we go, it's booting up right now. So the Redis read replicas are booting up. That'll take a couple seconds for those to get up and running. Let's go ahead. Okay, so they've started. Right now, it looks like they're okay, but they're actually probably just downloading the Docker images and setting them all up. So they're really not quite ready to accept requests yet. Yeah, the external IP right now is set to ephemeral, so it'll just kind of allocate one of the IP addresses from our pool of external IP addresses. You can reserve IP addresses on Google Cloud, and you can specify which IP address you want to associate with the instance. But right now, it's just randomly generating from our pool of external IP addresses.
So what you have is multiple instances each running one Docker container, not multiple containers on one instance.
That's correct. I have multiple instances, and there is one Docker container on each one of these instances. Yep, that's correct. So what I'm going to do now is I'm going to add an autoscaler to the read replica cluster, and I'll do that pretty straightforward. I'll say gcloud preview autoscaler. Add this to US Central 1F. I'm going to create a Redis read autoscaler. Maximum number of instances that I want to boot up is going to be 10. And I'm going to target CPU utilization of 30%. And that's 30% across the entire cluster. And actually, I'm just going to copy and paste the rest of it here because it is kind of a beast of a command here. So let me just copy and paste this. So we're targeting that instance group that contains our read replicas. Okay. Okay, there we go. So we have autoscaler. So now when the cluster CPU utilization goes above 30%, we're going to add more instances of those Redis read replicas. There is a default back-off period of, I think it's about 60 seconds. So we're going to target 30% CPU utilization. Once the requests have diminished, then we'll wait a minute between operations of deleting those instances. You can specify that cooldown period. Actually, I have that in one of the subsequent slides where we do that for the HTTP front ends. But you can specify the amount of time that it should wait before resizing the cluster. Okay, so let's go ahead and create a forwarding rule. A forwarding rule is going to generate a single IP address that you're going to use to access that cluster. So let me go here. gcloud compute forwarding rules. I'm going to create a Redis read forwarding rule. It's going to forward requests to port range 7000. This is going to be in US Central 1. And the target pool is going to be this Redis read target pool that we've set up with autoscaling and with health checks. Okay, so this is going to generate a public IP address in, this might take a couple seconds. Okay, while that's running, let's talk about what we've generated so far. So we have created this Redis master instance. It has its own external IP address. We've created these read-only replicas that are autoscale enabled. They're listing on port 7000. When I just ran that last command, it's going to spit out a public IP address. So the problem, though, is that there is a compute engine firewall that's blocking all requests from the outside world to these instances. We're going to set up our HTTP servers so that they have two connections to Redis. One connection is going to be the write connection. It's going to be writing everything to that master instance. And then the other connection is going to be for reads. And that connection is going to read everything from this read-only group. But right now, we can't do anything because we have this firewall there. By default, when you create a network and compute engine, all the ports are blocked off to the outside world. It's up to you to define which ports you want to open. And you can also specify which IP address ranges you want to open them. So we're going to do that right now. Let's go ahead and open up these ports. And actually, let's just make sure that our last command completed properly. Okay, there we go. So there's our external IP address. You guys can't access it because of the firewall. Once I open up the firewall, you will be able to access it. Please don't, at least for the duration of our demo. Yep.
So I thought you also created a HTTP network.
Mm-hmm. That's correct. I have.
Can we tie the two networks together so that it isn't really open to the outside world?
Yeah, exactly. That's we're going to do that ultimately at the end. Yeah, so we'll talk about that at the very end. Yep. The question was, how do we tie together the Redis network and the HTTP network? And the answer was that we'll get to that soon. So what I'm going to do is I'm going to open up the firewall. I'm going to say gcloud compute firewall rules. We're going to create our Redis ports rule. It's called Redis ports, and we're going to allow traffic, TCP connections on port 6379 and port TCP 7000. The network, Redis network, in the project, Google Platform Demo. That's going to open up those ports to the outside world. You can also specify which IP address ranges you want to open them up to. And the way that you would attach the networks together, and we'll talk about this at the very end, is you would have a gateway server that's sitting in front of all the HTTP servers. All of their requests is going to go through that single gateway server, and then you're only going to allow that gateway server to be able to access the Redis cluster. You're going to open up these ports only to that gateway server. So that's basically what you'd set up. We're also going to open up the HTTP ports on our HTTP network. So let's allow TCP port 80 and TCP port 8080. Network is going to be HTTP network, and the project is Google Platform Demo. And just to expand upon what I just said about the gateway, we do have as a feature coming out soon the ability to generate an internal IP address from that load balancer, and that will resolve the issue of having to set up that gateway server in front of your HTTP front ends. Okay, so we've opened up those four ports. So let's take a break from all the Redis stuff and set up the HTTP front ends. And this is what we're going to create from right to left. We're going to start by setting up an instance group. We're going to add an autoscaler. We're going to add the managed instance groups to that. We'll attach this instance group to a backend service. This backend service is going to use health checks to make sure that that instance group is healthy. It's going to route requests to that instance group. We're only going to create an instance group in one of the zones, but the whole idea here is that if you want requests to be routed to the backend service that's closest to your end user, you'd create different groups in different zones, add them to the same backend service, and then it's going to choose which one's closest. We're just going to create a simple example where you just have a single instance group, though. Okay, so we're going to create the backend service, add the health checks. I'll talk about some of the other stuff at the very end here, adding a URL map, target proxy, and then a forwarding rule. So now what I'm going to do is I'm going to launch a container for my HTTP front ends, and I've already created this HTTP container YAML file. And what these HTTP front ends do is they have two connection strings to my Redis backend. One connection string tries to connect to this environment variable Redis read IP address, and the other connection tries to connect to this environment variable Redis write IP address. So in this config file, I need to set those values to the IP addresses that I've just created. So let me go back to my console, and I have my Redis master. This is the external IP address of my Redis master. I'm going to go ahead and copy that, and I will paste it into my HTTP container YAML file. That's going to be the Redis write IP address. Let me paste that IP address, and then I'm going to take the IP address from my load balanced read replicas. Copy that, and I'm going to paste that here. So now, once I save this, my HTTP front ends will know which connection strings to use, either connecting to the Redis write master or connecting to the Redis read replicas that have load balancing in front of them. Okay, so I've set that up, and now what I'm going to do is I'm going to create an instance template using that container YAML file. So we'll say gcloud compute instance templates. Create a container guestbook front end. So this is what I want my HTTP servers to look like. The operating system they're running is going to be that customized container VM v2014 929. That OS lives in an image project called Google Containers. Machine type is going to be F1 micro. Again, I'm launching these really small instances because I want to show, I want to hit that 30% CPU limit. That's why I'm launching these really underpowered instances. We're going to attach these to the HTTP network, and the container.yaml file that I just modified is right there. We're going to attach that to Google Platform Demo. If you launch Compute Engine instances that are at least 2 core instances, you will get dedicated CPU cores, so you're not doing any sharing of the CPU with anybody else on the physical machine. So again, that's something that's really really compelling about our platform as well. You get dedicated resources. You don't do any of that time slicing or time sharing of CPUs with anybody else on the server. So again, we're in this case we are doing that. We're using the micro instances that are shared, that are sharing the CPU with other users. So I've created that instance template. I'm going to create a manage instance group. I'll say gcloud preview manage instance groups in the zone US Central 1F. I'm going to create guestbook front ends. The base instance name that I want to prepend to my instance is going to be guestbook, and it's going to be guestbook hyphen some random strings. Project Google Platform Demo. I'm going to start off with a cluster of size 2, and then we have to specify the template that we just created, which is container guestbook front ends. Okay. So when this command completes, you should see some guestbook front ends being created in this project. Here we go, guestbook front ends. There we go. It's going to take a couple of minutes for those to get up and running, but once they are, then we'll be able to connect to them, and we should be able to see the guestbook application. And this is something that I created. I'm not a designer. I'm actually really terrible with CSS and style and all that. So I really couldn't even get it to look great. But anyway, that's what it looks like when we connect to it, and we'll do that in just a second. In the meantime, I'm going to go ahead and add the autoscaler. And I will go ahead and just copy this entire command rather than having to type it all out. And let's look at some of these options that I just chose. We're going to scale up to 10 replicas. Our target load balance utilization is going to be 30%. I'll talk about what that means in a second. And our cooldown period, your question was, how do they resize when the peak demand goes away? We're going to wait 20 seconds between resizing the pool. So the peak demand comes, it goes, and then once it's gone, we'll wait 20 seconds. We'll terminate an instance. We'll wait another 20 seconds. We'll terminate another instance.
Earlier you mentioned the fact that the server, because they're running Docker, they're not quite up yet.
Yeah.
How does it know whether or not to put into a load balance?
It would know because they would not respond to the HTTP health checks. So
it's waiting for a successful health check.
Yeah, exactly. And I actually haven't set up the health check yet. But if you didn't add them in this state to that, then they would not, requests would not go to those instances. There are a couple of additional autoscaler options when you're doing HTTP load balancing. I'm sorry, HTTP autoscaling. You can scale, of course, on CPU utilization, where you want to target the overall CPU utilization of the cluster. You can also target request rate. So when you create a backend service, you can say, I know that each one of my backend servers is capable of X requests a second. I know it's capable of 1,000 requests a second, or 2,000, or 50, or whatever it is. So you specify that, and then you target the percent utilization of that overall request rate. So if you know that your servers are capable of 500 requests a second, and suddenly they're getting more than 300 requests a second, you can say, I want, at 60% utilization, I want to spin up another instance. You can do that. And you can also define a custom metric. You can say, I want to scale up based on bytes sent or bytes received, or some other metric that's defined. If you're interested in that, you can go to that link right there that's in the presentation. Let's just take a look at what we've done so far, setting up our front ends. We created the instance group. We've added the auto-scaling, and we have one zone in place. Now what we want to do is we want to set up the health checks that are going to run the HTTP health checks. And we're going to create the backend service, which is going to route requests to that piece. So let's go ahead and create the health check. Okay, we'll say gcloud compute HTTP health checks. We're going to create an auto-scale pool health check. And we're going to check every 5 seconds. We're going to request. Just at this base URL /. You can put whatever request path you like. The unhealthy threshold is going to be 2 consecutive failed requests. So if it fails twice in a row, we'll mark it as unhealthy, and we won't route any requests to that instance. And we're going to ping these health check requests on port 8080 because that's the port that our backend instances are listening on. So it's going to go ahead and create that health check. All right. And all right, so we don't manage instances, automatically health check the servers to make sure they're up and running. Why do you need HTTP health checks? Manage instance groups, ping the servers to make sure that they exist, but these HTTP health checks are making sure that they're able to serve HTTP requests properly. So that's the difference between the health checks that we're setting up versus managed instance groups. Let's go ahead and create a backend service, and then I'll talk about some features of backend services. Okay, gcloud compute backend services. We're going to create a service called guestbook backend service. Project is going to be a Google platform demo. The HTTP health check that we're going to pass to it is going to be the one that we just created. And all incoming requests to our HTTP load balancer are going to be coming on port 80. What we're saying here is take those requests on port 80 and map them on our backend to containers listing on port 8080. So you can specify that here. I'm just going to give that a name, port name www port 8080. So go ahead and create that backend service. What is a backend service? Backend service routes HTTP requests to servers based upon their service capacities. That can be CPU utilization, it could be requests per second. They will also take care of HTTP health checks and so basically load balancers target the backend service. So you have a load balancer as a single IP address, and then it sends that request down to the backend service. The backend service is also what you would do if I wanted to add a cluster in Asia that's close to my users there. Then I would go through this whole process that I went through of spinning up the servers in a different zone, and I would add them to the backend service. So in this case, what I'm going to do is I'm going to add my cluster to the backend service. The G-Cloud Compute Backend Services. No, in the previous step, I created the backend service. Now I'm adding a cluster to it. I'm going to add a backend, this guestbook backend service. Front ends, and the zone where that exists is US Central 1F. So again, if I had another cluster in a different geographical region, I would keep adding those clusters to the backend service here. Okay, so let's review again what we've done to this point. We've set up our clusters, we've set up the backend service with health checks, and now we just have to do the rest here, setting up the URL map, the HTTP proxy, and the forwarding rule. So we're really close to being done. Promise this will go really quickly here. Let's go ahead and create a URL map. G-Cloud Compute URL Maps. I'm going to create the guest book web map. And the default service is going to be guest book backend service. So what does this mean? This doesn't really tell you too much about what URL maps are capable of. We're taking all requests and we're routing them to that one backend service. But what you can do is you can set up something where requests to mail.mysite.com or sites.mysite.com or docs.mysite.com all go to different backend services based on a pattern of URLs. Or you can do something like, let's say you have a URL that's like /create_user, probably something that's just going to enter a couple of records in the database, really simple. You can have a cluster of one core machines doing that. You don't need it to be that big. But let's say you have another URL that's /render_video. You want a huge cluster of like 16 core machines to be doing that kind of thing. So you can route these requests to different pools of resources that have different computing capacities. In the example that I just did, we're taking all requests and sending them to the same backend, so it's a really trivial example, but I just wanted to let you know that with URL maps, you can set up something that's really a lot more sophisticated. Okay, so now let's create an HTTP proxy. Let's see, G-Cloud Compute, target HTTP proxies. I'm going to create a guestbook web proxy. And the URL map that I'm going to forward requests to is going to be this guestbook web map. So what does an HTTP proxy do? It simply forwards incoming requests from that forwarding rule to a target URL map. It's pretty much it. You just set that up there, and okay. So now that we've set up that proxy, let's target it in our forwarding rule. So I'll say G-Cloud Compute Forwarding Rules. We're going to create a guestbook HTTP rule. This is going to be on port 80 because it's going to be an HTTP forwarding rule. Our target HTTP proxy is going to be guestbook web proxy. And we're going to say global, -- global. And what that global means is that it's going to generate a single globally available IP address that you can use anywhere in the world, and will route those requests to whatever region is closest to your end user. So, maybe on other cloud platforms or something, or on your own infrastructure, you might use, DNS to say, this is the IP address of this cluster in this region. This is the IP address of the cluster in this region. You don't have to do that in Google Cloud Platform. You simply generate this single IP address, and you can use that all around the world, and we'll automatically route that request to the closest service for you. So that's what that -- global option does for you. And that's it. There's your IP address that you're able to access. If you try to access it now, it's going to fail because it takes a couple of minutes to propagate to throughout the global DNS network, and also it typically takes a couple of minutes to get up and running so you can connect to it. So let me just try that. I doubt it's going to work.
So I guess this is where you also find
For SSL termination, right? So the SSL termination actually has to happen on the servers themselves. We don't currently have it on the load balancer, so you can manage the certificates on the back end. But that is a feature that's coming this year.
Is this IP dedicated to that service? Shared.
The IP address is dedicated to the service, so you're not sharing that IP address with other websites in the platform.
But dynamic. I mean, how do you actually do this in DNS now?
What do you mean?
So I mean, like it's a SSL termination, for example.
Yep.
It's pretty expensive on Google Cloud.
Right.
But here you say this is my own language.
Yeah. So if you want to, it is that you want to have SSL termination on different.
Maybe not, but I'm just asking, like, does it cost more?
To have this single IP address.
Yeah.
It does cost, so I believe it's like 2.5 cents per hour per forwarding rule that you have. And you're also charged a ½ cent per gigabyte network egress charges.
Nothing for the
Nothing for the IP address while it's in use. If you want to reserve an IP address, then you pay something like 1 cent per hour when it's not in use to reserve it. So you can reserve a pool of IP addresses, and you can when you're not using them, that's when you pay for it, and then when they're in use, you don't pay for it. So.
But local IP address you can somehow tie to the address name of the company name?
You would so we do have Google Cloud DNS where you can specify that. You would basically just tie that to whatever www.companyname.com. But you would just use this IP address to do that. Yep.
But then he's actually trying to paste that something else that doesn't fit the DNS name.
Right. Right.
That's part of creating the IP address.
It doesn't automatically update whatever DNS records that you have. Right.
Hates the manual.
Right. Yeah. So yeah, there are some steps like that where you might have to do some manual intervention. But let me see if we're able to connect to this now. If we're not, then I can connect to one of the backend instances and just see if that's up and running. So I have the external IP address of my guestbook instance. I can copy paste that. Okay. This might take a second to connect. Any additional questions while we're waiting for it to?
So it's only HTTP, right?
Yeah. Well, the Redis part was not.
But the URL only HTTP.
Yeah.
Can you use this as other protocols, like this load balancer?
So the HTTP load, there's the HTTP load balancer, and then there's the network load balancer. So the network load balancer you can use with any TCP or UDP based protocol. HTTP has to be only HTTP.
Is there any session stickiness?
You can specify session affinity based on either 3-tuple or 5-tuple. So you can say source, target, IP, and then protocol. We can say source, target, IP, source, target, port, and protocol. So if you wanted some additional stickiness, you would specify the 5-tuple.
And it's using a cookie or something?
It's hashing that tuple. Okay. So I think the grand finale is a little bit tricky here. I might just post this in the comments afterwards when everything's up and running. But it can take up to an hour for this to actually fully propagate and be fully available. So unfortunately, we've come to a demo where it's not popping up. So I can't quite demo it, but I will paste it in the link, and you guys can test it out and run some benchmarks against it and see how auto scale. So yeah.
Could you go maybe to like your initial overview?
Sure.
Slide and maybe talk about the billing, because I was reading the docs on the network egress billing and things like that.
Yeah.
I'm a little bit confused as to, with this multiple layer of load balancing thing, what is external egress in that diagram?
Yeah, exactly. Yep. So if it is an external IP address and it is a Google service that's accessing that, that is going to be charged. That's not going to be charged because the traffic's going to go to the edge of Google's network. We're going to recognize it's an internal IP address, and we're just going to redirect that to an internal service. So that's not going to be charged.
Okay.
The only thing that's going to be charged are these requests to port 80 and the responses basically from GDG.
But you're paying load balancer traffic at 2 layers, right? Because you pay separately at the 2 layers, because there's the Redis read layer and there's the external layer, and those both charge load balancer transit.
That's correct. Yeah, you are paying load balancer charges for the traffic that goes to the load balancer. It's not at the internet egress rate; it's at that like half-cent rate. But yeah, you are paying for that.
So when you said you talked about the global briefly.
Yes.
Global routing, but that only applies if you have instance pools set up in multiple zones. Otherwise, it always goes to the same zone regardless of the source location.
I believe that's correct. I'd have to get back to you on that one for sure.
You talked a little bit about there was a mention in there about DOS protections.
Oh yeah.
Talks about broken packets. Any other protection?
It protects against SYN flood attacks.
Yeah.
So there's
What actually happens?
To be perfect, what happens?
No, I mean like how does it recover?
Yeah, I'd have to get one of our network security guys to talk about that.
Is there any CDN kind of story in any of this, or you have to do yourself?
I would say the closest CDN thing wouldn't be in what I'm showing here. It would be in cloud storage. With Google Cloud Storage, you can mark assets as publicly available, and then you can set cache control headers on them. And if you do that, if it's publicly available and you set a cache control header, then we will store that in the edge cache network that we use for our own, YouTube and search and things like that. So that can give you CDN-like performance without you having to set up anything extra. Yep.
So I read about Facebook utilizing a client-side cookie to redirect reads to the right port or like 3 milliseconds, because that's how long it took to push the data across the country.
What did they do?
So basically, whenever a client writes
Yeah.
to the master, for the next 3 milliseconds, all requests go to the master.
Oh, I see.
Waiting for the replication to occur.
I see.
So I was wondering, would that be something that could be done with your forwarding rules?
Where it would forward the request to the master temporarily or something like that? I don't really know how you can set that up necessarily with this, where it would like switch over to a different cluster for load balancing. I'm not sure if there's a way to set that up. Cool. Is there a question? Yeah.
Yeah, Mike, I showed that instance script you saved earlier on. But are those scripts saved anywhere? Like, for example, GitHub, so you sort of afterwards tonight you can sort of replay that and do the whole demo yourself and just work with it end to end.
Yeah, I do have an autoscale script which has all these commands that I ran tonight, and it's about 90% of the way there because some of this involves getting the IP address and setting the environment variables and doing some set and awk stuff. So that's not quite done, but I will upload this so that you can take a look at it, try that yourself, and if you try to run this, you'll get some errors, and maybe you can debug it a little bit more. I haven't had the time to fully work out all the kinks, but yeah, I do have scripts that do all this. Important thing, if you're going to follow along and do this at home, you really need to make sure that you delete everything when you're done. And you can't just go through and click the instances in the console and hit delete, because the manage instance groups will make sure they're always up and running. So you have to actually delete the manage instance group. just something else to keep in mind. Okay, I talked about the gateway. Another thing, if you're doing something like this where you just need to auto-scale stateless front ends, you're doing it in Java or Python or Go or PHP, and it's really straightforward logic that you're writing from scratch, do it in App Engine if you can, because it's much easier. You don't have to deal with any of this load balancing, setting up things in different zones. That's all done for you automatically in App Engine. You literally just code to some APIs and it just happens. So it's really easy on App Engine. And two other talks that I wanted to plug real quick. There's going to be a talk at a MapR conference at the end of this month on January 29th about Google and big data. So if you're interested in the big data space, Hadoop, BigQuery, all that stuff, we're going to be speaking at MapR. And tentatively in February, we're going to talk about containers, what they are, what are containers, when do you use them, how do you set up containers on Compute Engine, how do you run with Google Container Engine. So that's tentatively coming in February as well. Yep.
With respect to that, can you compare this to a container engine solution a little bit in terms of like, because I mean I understand the app engine differences and why some things about why I might use Compute Engine versus app engine, but I'm not clear, especially in the load balancing and auto scaling scenarios, what the differences would be in these kind of instances and between container engine.
Right. I think it's actually it may be close to a container engine solution because I'm already using containers. I think maybe the main difference would be the fact that container engine is going to schedule where those containers are going to run. In this case, I just have a single container per instance. With container engine, you can pack on a lot more containers per instance. But yeah, it is similar because I'm just launching a pool of homogeneous servers. I'm adding load balancing in front of it. So
you get that for free basically. Most of the auto scaling and all that. You just set it up as parameters. You don't have to define it.
That's correct. Yeah. Yep. I also want to mention that everything that I did here on the command line, again, you can do through the web UI. You can also use deployment templates. So rather than having to run these commands one after another, you can specify everything in a single declarative template, and it'll just run it. It'll do all this orchestration stuff for you. So it can be a lot easier than what I've done. I just want to give this another shot and see if we're able to connect. Oh, please work.
I don't know what the state of the universe is between App Engine and Compute Engine in terms of because you talked about how if you're just doing simple stateless HTTP, it can be easier to do that in App Engine. But can you cross those now? Like, can my stateless HTTP front ends in App Engine access Compute Engine backend?
They can with a feature called Managed VMs. And what Managed VMs let you do is you can run the App Engine runtime in a container on Compute Engine. And then what you can do is you can install anything else that you want on that Compute Engine instance. And we will automatically make sure that that Compute Engine instance is running. We can auto-scale it, and then you can have whatever software you want. So that can give you, in addition to the flexibility, a lot more power because App Engine instances are typically not too powerful in terms of the amount of CPU and memory that's allocated to them, so you can get a lot more throughput by using Managed VMs. Okay, I'm a little bit disappointed this isn't working, but I will wait until it's working and then send you a link in the updated comments. So. Cool. Okay. So if anybody has the sign-in sheet. Okay, perfect. I'll update you guys with the completed solution.
Are you going to be sharing those slides so I can put those on the meetup site?
Yes, I will. I have the slides. They're actually currently shared on the URL that I showed on the first slide here, but I will also put them on the meetup site. Yep.
Okay, one last question.
Yeah.
Right at the end there, you said do this at home. After you've done, make sure you go back and get this back in this order. Is that so it doesn't sort of join your card after your credit runs out?
Yeah, that's pretty much it. I mean, if you don't delete everything kind of in the reverse order that you created it, then it's just going to keep running and it'll charge you at some point. So you do want to make sure that you delete all the resources when you're done with them.
Any other tips on how to do this yourself rather than work? How to do this for cost?
Yeah. If you're not using the starter pack credit, you don't really care about using that. Like you just want to spend a couple of dollars here and there. You could just create a brand new project, enable billing, use it, and then when you're done, delete the project, and that will delete everything associated with it. And of course, we can't charge you more if you delete the project. So we'll charge you for whatever you used while I was alive. And billing is down to the minute as well. So that's another feature of the cloud platform where if you run like a minute into the next hour, we're not going to charge you for the full next hour. We'll just charge you for that extra minute.
I noticed you used like the micro.
Yep.
Is that that's the bottom of the?
Yeah, that is the bottom of the. I don't want to say bottom of the barrel, but it is the smallest instance that we have. It is a shared core instance. My goal was to show how when the CPU spikes the auto scale, but I can't seem to connect to them. I'm not 100% sure why this was working last month when I gave this demo, so I need to look into this a little bit more. But yeah, the whole reason of using the smallest instances was that the larger instance, even the 2 core instances or 1 core instances can easily handle the volume of traffic such that they wouldn't auto scale. So I wanted to just use the smallest ones. Yep.
So if a typical user gets to this point, things are not working.
Yeah.
How would you debug this?
Yep, that's a good question. There are online forums on Stack Overflow that our support team is constantly monitoring. There's also email support and phone support, 24/7 phone support, so you can call up Google and get our team of engineers. We have a team here in Seattle and down in San Francisco and basically in many of our major offices. For this particular case, I know that it can take a while. I knew this was a risk. I know that it can take a while to actually propagate for this to actually work. So I know that there's really not too much I can do other than wait at this point, wait about an hour and try again.
Can't you bypass the front end to talk to your
Yeah, I did try that, and for some reason I can't connect to it. I'm not sure if I made a mistake in the configuration. I mean, I can actually just try to. What I will try to do is I'll run my script to delete everything and then recreate it, and maybe that will work.
Go into the web console, look around the VMs, and get information back.
You could. I mean, we do have everything that's logged here in Compute Engine. There is logging. Where is it here? Here we go, monitoring logs. So you can see all the operations that are happening on the project. Oh, that's for data flow. Oh, here we go, operations. I'm sorry. I'm just going to try again real quick before everyone goes to recreate the whole project and see if I just mistyped something or something didn't get configured properly. I know this works. I mean, you guys saw it work last month. So.
So there are tools to be able to trace what's going on and why things didn't look expected. You had a log there.
Yeah. I mean, exactly. You basically just kind of go through step by step and see what's working at this step, what's not working at that step. Then there's kind of.
With virtual machines, you log into the machine and see what processing.
Right. Exactly. Yep.
So you have like delegation management, like for example, you have like a split user and you can delegate some of these tasks. That means.
So you on the project level or for the individual virtual machines?
Like, so for example, you have a large organization. I would expect maybe one person or two people to manage these different VMs. So
Yep.
Some of the project or
Yeah, that's a good question. There are different roles within a project, so you can set these permissions. The roles are not too fine-grained. However, they are pretty much limited to owner, editor, or viewer. So if you wanted to restrict permissions in addition to this, you could either create different projects with different people who have different roles, or you could use some cloud orchestrator or software that manages that aspect of it at a finer detail. Yep.
I saw you were running that the only option, and I think there's REST API.
Yeah, G-Cloud is not the only option. There's a REST API, there's the Web Console. There is Deployment Manager, which allows you to script everything that we did in terms of creating these clusters, configuring them, running commands on them, creating load balancers. So basically everything that I did on the command line step by step, you can define it in a declarative template and then submit that template to the Deployment Manager service, and it will set that up for you. It depends on what you're developing. Like, are you talking about developing some software that manages all this?
Yeah, I'm building it so that depending on what cloud platform you want to actually, that's a
Got it.
So I was trying to figure out.
One thing that you might want to take a look at is the Google Cloud client libraries. We do have a couple of client libraries for Python, Java, a bunch of other languages, and this makes it really easy to do the OAuth dance to get those tokens to make the REST requests rather than making the individual REST requests and having to parse it. It's already in these APIs. Yeah, so this makes it a lot easier if you're building third-party software to interact and like drive the service. I think this is really what you'd want to use instead. Yep.
If you get your demo up and running,
Yeah.
what do you do to force the auto scale when it's first scale?
What
How
I
do you sign the guest book?
Yeah, I run Apache Benchmark. So if you, on your Linux machine, you install Apache 2 utils, and then that comes with a command called AB. And I say AB-N, like 10,000 requests, 10 concurrent connections at the URL, and just slams it, and then you can see it scales up. Let me just create it. Other questions? Okay. Well, I think that's about it. Feel free to. The big data talk at MapR won't be as like command line oriented. It'll be more like business tech focused. And then next month we're going to have product managers and engineers from the container team come and talk. So it's not just going to be me. It's going to be a little bit more of a forum with those guys. So. Nope.
Thanks, everyone.
This does not look good.